Hey everyone, so this is the lecture on the measures of the location of data. So we're going to be talking about how to kind of differentiate between data sets and looking at the location or spread of data from the standpoint of quartiles. So let's look at two data sets just to start, to kind of get a feel for why we might want to do this. So the first one's just going to be the average monthly temperatures for San Francisco. And then the second row is going to be the average monthly temperatures for St. Louis, Missouri. So what is the average yearly temperature for San Francisco? So here we're going to use the term average to say the sum of the data divided by the number of the data. So it's the average that we always think about. We'll talk more next week on different types of averages. So using this method, the average being the sum of the data divided by the number of the data, we would get 57.5 degrees Fahrenheit for San Francisco. And the average yearly temp for St. Louis is going to be 56.1. And those are really, really similar temperatures. Like, I don't think we would be able to determine just standing outside if we were standing in 57.5 or 56.1, because they're so close. But now let's look at the min and max for San Francisco. So the min is 51 and the max is 63. The min and max for St. Louis, however, are 30 and 79. So those are also really different. For sure, I could tell the difference if I was standing in 51 degrees Fahrenheit or 30 degrees Fahrenheit, absolutely. And similarly, I could definitely tell the difference between 63 degrees Fahrenheit and 79 degrees Fahrenheit. So even though the averages are really similar and probably indistinguishable from a I'm standing outside, how hot is it standpoint, whereas the min and max, they're showing a little bit of a different story here. So is the average that we computed meaningful? So let's look at the range. Maybe this will tell us a little something. We talked about the range last time, and the way that we compute the range is we first identify mins and max, and then we take the difference. So it's going to be the the maximum minus the minimum. So 63 minus 51. And so the range for San Francisco is 12 degrees. The range for St. Louis is 49. So now we're kind of getting back to that bigger picture. Even though the averages were the same, we're getting a lot more variation from St. Louis than we are from San Francisco. So how can we quantify this data and interpret this data and present this data in a way that's more meaningful than just taking that average that we saw initially? So the way that we're going to do that is we're going to talk about the median. So the median is a way to kind of look at and digest information from a data set. So we divide the lower half of the data set from the upper half. The way that we do this, it depends on how many data values we have. So if the number of data values is odd, then the median is a number from the data set. If the number of data values is even, then we take the midpoint between the two middle data values. So let's look at that in action. So with 9 data values, our middle data value is right there on the list. It's actually 9. So we can see here that we have 4 data values to the left, 6, 7, 8, 8, and we also have 4 values to the right, 10, 11, 13, 15. When we have only, and the median is 9. When we have only 8 data values, we can't select a data value from our list because it wouldn't be in the middle. If we chose the 8 in the left of that pink box, we would have 3 values to the left, but 4 values to the right. Similarly, if we chose the 9 from that pink box, we would have 4 values to the left and 3 to the right. So if I select 8 or 9 from that pink box, it's not really going to give me the middle. So the way that we do this is we take the midpoint between 8 and 9. So the midpoint is computed just by adding those 2 values together and dividing by 2. So 8 plus 9 is 17. We take half of that by dividing by 2, and we get 8.5. So for us here, the median is 8.5. We also can further our presentation of this data by looking at quartiles. So the lower quartile divides the lowest fourth of a data set from the upper 3/4. It's the median of the lower half. It's the half of the half on the left side. If the number of data values is odd, exclude the middle point in this calculation. The middle quartile is just the median of the entire data set, and we just saw that in the last slide. The upper quartile or third quartile divides the lowest 3/4 of a data set from the upper fourth. So it's the median of the upper half. It's the half of the half on the right side. And we're also going to be paying attention on whether we should exclude the middle value in the data set when the number of data points is odd. So let's look at an example here. We have 8 data points. So we can actually split up our data evenly half and half by taking the 4 bottom and the 4 top. So we saw previously here in this example that the median was 8.5. If we wanted to compute the upper quartile, we would again take the half point, the median of the top 4 values, in the same way that we computed the median before. So that's taking the midpoint between 10 and 11. So again, taking the midpoint just means adding those 2 values and dividing by 2. Similarly, we're going to do the midpoint between 7 and 8 on the bottom half. When we have the 9 data points, we saw earlier that 9 was our center value. We had an odd amount of data values, so our median was actually a listed data value. So, remembering that if the number of data values is odd, exclude the middle point in this calculation. So now that we've done that, we can actually split up the top and bottom. Whereas before, the top and bottom included every single number in the data set, now we're separating the top and bottom by excluding that middle value. And we're going to go ahead and take the median of these halves as we did before. So the midpoint between 7 and 8 is 7.5. The midpoint between 11 and 13 is not that number. This should be 12. I'm sorry, I'll fix that later. All right, so that mistake aside, it should be 11 plus 13 over 2, and it should be 12. So yeah, there's multiple mistakes in that way. How embarrassing. That's okay. So let's do another example. Let's find the quartiles for the following data set. So here we have a list of data. The first thing you want to do is order your data, because if it's not ordered, you can't find the median or the quartiles. So once your data is ordered, go ahead and locate the median first. So for us, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values, we know that our median is going to be among the list. So it's going to be that middle 13 right there. Then we split up left and right halves. And from here, we can see in the lower half, we have 1, 2, 3, 4, 5 values. And in the upper half, we have 1, 2, 3, 4, 5 values. So one, that tells us that we did the split correctly. And it also lets us know that if I want to take the median of this lower half, because there are an odd number of values in the lower half, my median is actually, or sorry, my first quartile and my third quartile are actually going to be numbers from this list. So I get 11, 13, and 18. As another example, it'll be a little bit different. We still have to order. And then we have an even number of data values. So for this guy, we're going to take the midpoint between 2 and 2. It's just 2. It's what you think it should be. Then we're going to go ahead and actually include those 2s that we used in the median, because we only exclude the median from our computation of quartiles when we have an odd number of data values. We have an even number of data values, so I'm going to split it equally in half, and it'll include all the values from our data set. So we're going to do the same thing for the lower half and the upper half. We're going to have to take the midpoints here, but again, the midpoint between 1 and 1 is just 1, as the midpoint between 3 and 3 is just 3. All right, interquartile range, what is it? The interquartile range is a number that indicates the spread of the middle half of the data. It can help determine potential outliers. A value is suspected to be a potential outlier if it is less than 1.5 IQR below the first quartile or more than 1.5 IQR above the third quartile. So the way that we calculate the IQR is we just take the difference between Q3 and Q1. So think about this, interquartile range. It's just the range between the Q1 and the Q3. And we know that range is max minus min. So we can kind of think about it in that sense, where Q3 is going to be the high value, Q1 will be the low value, and we just take the difference. So let's look at this example. We have employee salaries from LGX Co., and they're listed in the tens of thousands of dollars. And we'd like to determine which values are potential outliers. So in this table, we have 15 values. So the 67 represents a person who earns $67,000 per year. So anyway, so that should be, it should say listed in thousands of dollars. There's another error, sorry. So we have 67, 98, 72, 65, but we have this big one here, it's 350, quite large and definitely much larger than the other values we see. So how do we determine if it's a potential outlier? We have to go through and we have to determine what our quartiles are. So we order the data. We have 15 values. So we know that our median is going to be one of our values from the list, it's 67. From there, we split into lower and upper halves. And then what we're going to do after that is we're going to determine Q1 and Q3. So we have 7 values in the lower half and 7 values in the upper half. Because I have 7 values, that means that my Q1 is actually going to be a number from the list, 55. Similarly, Q3 is 88. So now we're ready to compute the IQR. The IQR is Q3 minus Q1, which for us is 88 minus 55, giving us 33. So if I'm 1.5 IQR below Q1, that means to say who's too low or what's too low, I take Q1 and I subtract 1.5 IQR from that. So that's 55 minus 1.5 times 33, and I get 1.5. So that tells me that any value below 1.5 would be an outlier. Similarly, if I'm too high, I would have to be 1.5 IQR above the third quartile. So to compute that, I do Q3 plus 1.5 IQR. So that gives me 88 plus 1.5 times 33. Putting that in my calculator, I get 137.5. So anything above 137.5 is going to be an outlier. So looking at our data, we see that 350 is an outlier. It's too high.